Hey Dad, I just want to give you an update on the circuit I've been building. So here is the clock that I showed you the last video. It basically is 555 chip controlled. It has a pot here to change the clock speed. I can slow it way down or speed it up so fast that it just looks like the LED up there is on. But for our purposes, I am going to turn it down to a manageable speed so we can see what it's doing. And then here's the counter that I showed you, which is just counting from 0 to 15 in binary. If I set this to manual and step through it, you'll see that if I pulse through, it lights the 1, but then because the chip has a carryover, it's going to automatically click the clock for the second circuit within the chip, which is going to then count this one. So the clock pulsed once, that one went off, that one went on, and when the clock pulses again, that one's going on. But now this is, when the clock pulses again, this is going to set the carryover, which pulses the clock for this one, which then is going to carry over and pulses the clock for this one. So if you step through it, you see how it's just counting in binary and it just keeps on going. Now I've only got 4 bits here, mainly because it was just a test, but it's going to have 8 bits soon, because guess what? Most computers have 8-bit counters. And so that flows from there, and now I've got a new piece that I've added, which is this EEPROM, electronically erasable programmable read-only memory, which is a bunch of, I think, oxymorons. Erasable programmable read-only memory. But anyways, what that allows me to do is that allows me to put in a value, take the power off, and the value stays. So what I've done is I've taken that binary counter, and this lead right here goes into the low 4 bits of my address, so that the EEPROM says, okay, you give me 12 bits of address, 1s and 0s, and I'll give you an 8-bit value that's stored within that address. So it literally, it's 16,000 bytes or bits of addresses, which is basically, it's a 2K RAM chip or EEPROM chip. So I can put anything on there and store it. Now if you notice, there's only certain lights that are lit up, and that's because right now we're at address 0, which is, I'm pulling over from the counter. So if I click through and go through this counter, it's address 1 has that value, address 2 has that value, and 3 and 4 and 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And then back to 0. That allows me to store values in an address, but better than that, or cooler than that, I think. I mean, because that would be great. It's the same way that RAM works, and as I get more into building this computer, I have RAM chips that do the exact same thing, and so I'll be able to use the exact same type of program counter and go through which, read the next address, execute a command. But this, and oh, by the way, this EEPROM is going to factor in big time in the executing commands, because it's going to hold the commands that I want, the output that I want. So if I load a command and it is 0000, which could be anything, I'm going to send signals to these different pins, which is going to go to some section on the board that's going to perform an action, whether it's add 2 numbers or put this value into this area or whatever. That's going to control the whole computer. But what I'm actually working on right now is I can set up a decode table in here, and it seems weird to use a 2K chip just for a decode table to light that. So if you imagine, we have a binary input right here, and there is no real easy way to convert binary to lighting a decimal, or lighting a decimal digit. So if I put the decode in there to say, when you give me this value, put out the bits that make this all a 0, that makes the 0 light up. And then when we go one more and we get to the 1, you give me the pulses that'll have to light just the one line. And we could do that all the way up to 15, which I didn't actually realize it until working with this, but in hexadecimal you've got 0 through 9 and then A, B, C, D, E, and F, which all display on a single 7-segment display. And so 4 bits makes up 1 hexadecimal digit. Just kind of cool. And then the other thing that I realized in doing all this, let me switch this clock back to automatic and let it run through. You notice how we got all these lights flashing? It looks a little bit like the science fiction. Let me turn up the speed here just a bit. It looks a little bit like the science fiction computers, which I now understand they weren't just something for the movies flashing pretty lights. This is actually displaying stuff that's important. So on this model, this would be the address right here, and this over here would be the value that's in that address. And that might be something that's very important to display at any one time. So they weren't just really weird flashing lights. They actually had purpose and meaning to people who understood it, kind of like life, you know. But the other side of it is that the Altair, the first home computer that came out, had switches and lights just like this one that allowed people to program it. So let me just show you this. I'm going to take off the output on these LEDs. So if you look at this, I'm on address whatever that is, the 2 in the middle. I'm in the 2 in the middle address. I'm going to take that off, and I'm going to actually reprogram this value to be something totally different. Let me plug in one of my cables. I'm just going to make it a binary 1, which would give me okay, let me go on. I'm sliding around, sorry. A binary 1. I'll put it into this LED. Notice that one LED, oh, there you go. Notice that one LED is lit. I'm going to push this button, which sets the right enable on the chip. And then I'm going to pull that power out and do the output enable again. Notice that 1 is still there. So if I cycle through this entire count here on the counter, until I get to that address, notice that one LED is lit up. So I've effectively reprogrammed the computer using nothing but a switch, and I've got the counter hooked up, but notice that right here, I've got all these wires going to a dip switch. I originally was programming it just by changing the dip switch to change the address. And actually something very interesting, if I change one of these higher order switches, notice that all the lights are lit up, and that's because in EEPROM the default state is 1. Every bit is set to 1 until you program it. So if I turn the clock back to normal, notice the clock's going through, all those values are set to high. That's because I changed the address using this dip switch. Change it back, and now all the low order bits are changing because I programmed it with this high bit at 0. So that's a totally different set of addresses. So just kind of cool. I'm learning a whole bunch. It's fun. I'm just, again, does this have any practical purpose other than me learning? No, but isn't that what life is about? Is just learning and expanding ourselves. So I hope you enjoyed. It's fun for me, and as I get more modules built and as I add more functionality, I will definitely post more videos because it's fun for me and I like to go back and see it, but I also hope that other people get a kick out of it. So let me see if I can zoom back just a tad, and yeah, there we go, and you can see the whole thing. See if I can focus better. Jeez, there we go. So So there's my computer so far, and all it does is it counts to 15 and then uses those 15 to pull out a value out of a memory. That's it. So anyways, hope you enjoyed. Until next time, have a great day. Love you. Talk to you later. Bye.